Activity 7.3 lets you practice some of the knowledge that you picked up in the tolerances PowerPoint. So you should have that tolerances PowerPoint out as you're doing and as we're going over this document. So I'm not going to read this to you, but you should read this document to see that it's all about the variation that happens when you manufacture parts. So this first page, really, there's nothing that we're going to attack on that. Let's go ahead to the second page. Okay, on the second page, they give you an adjustable rocker arm, and they go ahead and provide you with all the dimensions. Now, they ask you to go in and highlight the different kinds of tolerances that they have included with the dimensions. So, a word about this. When you see numbers that look like, say, this one, or this one, all of these that do not have any tolerances written next to them, you need to immediately come down to this text box, the bottom of the page, and recognize that they have tolerances. So for example, the 6.13 right here, which is a length of this rocket arm, it has a tolerance of plus and minus 0.03 because it has decimals to the hundredths. So make sure you understand that. That is a key factor. And just a point as we go forward, when you do the exercises, this is the whole of which they're speaking. And we'll talk about this in the future, but that is the hole. They want you to put this rod through this hole. This is the smallest hole, and you can see that by the limit dimensions. Speaking of limit dimensions, this format, which I'll circle in blue now, that's a limit dimension. They give you the high and they give you the low. So that's a limit dimension. You have another one here and another one here. So those are the kind of tolerances that we have listed so far. We have the general tolerances, which happen in this box down here. You add that to each of the different tolerances they have listed. And then we have limit dimensions, which were the three blue that I've circled. Okay, let's move on to the... Alright, let's look at the base plate next. I believe that's on your page 3. And for the base plate, they give us some other tolerances that we want to focus on. So in red, this time, I'm going to circle the bilateral tolerances. So here's a bilateral tolerance. It's bilateral because it says plus and minus the same number. So we have one of those. Then we have another kind of tolerance right here. And that one is a unilateral tolerance. It's unilateral because look at the bottom number. That's minus 0. So that tells me that you only have a one-sided tolerance. This particular hole can only be increased, can be acceptable if it is between, let's see, 0.50 or 0.003 greater, in that range. It can be a little tiny bit bigger, but it cannot be any smaller. So that's how you should read that, and that is a unilateral tolerance. And on this particular drawing, we have the limit dimensions as well. So you've got all three in this drawing. For the ones that are not labeled, you have the general tolerances, which are right down here. So remember to look there if you don't have tolerances written on the piece that you are trying to create. Alright, now we're going to turn to page 4 because that has the problems I really want to have you understand. So let me just go ahead and adjust my page so that it looks like your page. Alright, question number 2 says the following. It says, consider the adjustable rocker arm represented in the drawing above. So you need to flip back to the drawing that we did. Let me just see if I can do that in this slide. Alright, so I can't back up and show you. But remember in slide 2 when I said to look back at your rod, the adjustable rocker arm, and look at the smallest circle. That's the circle you're going to put this rod through. So a couple of clarifying pieces. This rod that you're seeing, okay, right here, this rod has this diameter. Okay, that's all associated with the same piece. This diameter does not refer to the hole on the adjustable rocker arm. So make sure you understand that. Let me draw in here what that hole on the adjustable rocker arm looks like. So it's a hole, so it has a center mark, and it has limit dimensions. So it says that the diameter is from 0.536 to 0.531. So that's the hole that this rod is going to go through. So that's important information. Okay, let's keep reading because there's some important stuff in here that I want to make sure you understand. So for one, as we're reading, it says an axle is to pass through the smallest hole. Here's the smallest hole, and I just drew. The manufacturer is considering buying bar stock for the axle that is manufactured according to the following drawing using the same tolerances as those specified on the rocker arm drawing. Again, you've got to go back to the rocker arm drawing because the only tolerances I see are right here on the diameter of the rod. I see that I have a unilateral tolerance, okay, because it says plus 0.005 and then minus 0.000. So if you go back to the adjustable rocker arm and you look at the general tolerances, which they're talking about here, I see that anything that has one decimal point, it's plus and minus 0.03. So let me check this a little bit closer. Okay, looking back at that, I am not certain, so I'm going to tell you how I'm reading it. I see that it says .xx equals is plus and minus, right, 0.03. So we're going to go with that. I'm not sure if that's what it says, but that's what I'm reading, so we're just going to go with that. So when you have the rod length of 3, what's built into it is this plus and minus 0.03. So the first question is, what is the tolerance, the acceptable amount of dimension variation for the diameter of the rod? So to get the acceptable amount, what you're going to do is figure out what is the biggest rod you can have. What's the diameter of the biggest rod? So you add 0.005 to 0.525. Okay, that 0.005, that 5 adds to the other 5 at the end of 0.525, and I am getting a highest diameter or widest diameter of 0.530. Again, I got that by saying 0.525 plus 0.005. Okay, these 5s were in the same spot. They add up. The 2 becomes a 3, and that's the largest diameter. Okay, what's the smallest diameter? Take your 0.525 and subtract away 0. So if you subtract away 0, you get 0.525. Do that subtraction, and I get 0.005. So this answer is 0.005. Hope you understand that. So looking now at the tolerance for the rod length, remember I told you that we're going to use this information because that's how I'm reading it. So what's the biggest rod length you can make? Well, it's going to be 3.03. How do I get that? I say 3 plus 0.03 because that was from the general tolerance. What's the smallest one you can make? Well, it's going to be 3 minus 0.03, and that's going to be 2.97. I've run out of room, but if I subtract them, that difference will be 0.06. So that is your answer. This is your reasoning, and this is the work I would expect to see? Okay, so for the first one, this was your answer. This is your reasoning. And this is the work I expect to see. Okay, don't just write down the answer. You'll never be able to go back and understand what you did. All right, is the fit between the rod and the hole a clearance fit, an interference fit, or a transition fit? Explain your answer. Okay, we're only looking at the diameter of the rod. So here's my rod. Okay, its diameter is from, looking at my work in A, the biggest it can be is 0.530, and the smallest is 0.525. Okay, that's the rod information. All right, the circle information, so I'm going to put it here, circle information. It's what I had over here. The biggest it can be, according to the specs, is 0.536, and the smallest it can be is 0.531. So, the question is it a clearance fit? Will it go through? Interference fit? Will it not go through? Let's work on those two. So to figure that out, what I did is I thought about it and I said, okay, what is the tightest hole? What's the smallest hole I could have? And that smallest hole is going to be 0.531. Next I said, what is the largest rod diameter I could get? And that largest is, if we put it in red as well, is 0.53. So can a 0.530 rod pass into a circle that has a diameter of 0.531? And if the answer is yes, which it is, you have a clearance fit. So that's what it is. It will clear. It will pass through. Okay, let's go on to D, and I'm going to change pages. Okay, instead I just slid things up a little bit so we can see. Alright, so for D, I'm going to do some work, so I'm going to use the space down here. What is the allowance between the rod and the smallest hole? Well, first off, you need to know a couple of things. So you need to know that your allowance, okay, that equals your MMC of the internal, which is going to be the hole, minus the MMC of the external. Alright, well, what does that mean? Well, allowance is maximum material condition of the internal minus the maximum material condition of the external. So for you to maximize your material with the internal, you're going to make the tightest hole possible. So the tightest hole possible for that smallest hole on the arm is going to be, looking at it, so that tightness is going to be 0.531. That's your MMC internal. Okay, look back at your measurements. You had a choice of, for the hole, 0.536 to 0.531. Go for the tightest fit. Go with 0.531. Now look at the material measurements for your rod. You have a range of from 0.525 to 0.530. What will give you the most material in there? Well, clearly the larger one, which is 0.530. Subtract the two of them, and you have an allowance of 0.001. That is your allowance. It's the tightest fit possible. So if you think of it like that, that's going to help you. Okay, so tightest fit. Okay, so let's go back to E now. If the design of the assembled machine requires that the rod is sized such that the actual clearance between the rod and the hole is never greater than 0.005 inches, will the current rod design meet the requirements. All right, let's think about this. What would be our range? So on the one hand, we figured out that if we calculated the allowance, we had the small hole minus the large rod. So that gave us a clearance or an allowance of 0.001. What if we did large hole minus small rod diameter? So the largest hole that we could get is 0.536, and the smallest rod, is 0.525. If you subtract those numbers, you get 0.11. So they do not want it any greater than 0.005. So we're okay here, but we're not okay here. That's too big. So therefore, no, it does not meet the requirements. Okay, now we'll go on to another slide. Okay, this question says, or I'm on F now, the machine specification requires that the rod is no longer than 3.025 inches and no shorter than 2.955 inches. So let L represent the actual length of the rod. Write the length constraint as a compound inequality. So this is what you do to get a compound inequality. You put an L here. The L stands for the length of the rod. It can be no longer, so it has to be less than or equal to 3.025. And it can be no shorter, so it has to be greater than or equal to 2.955. And these are both inches, so I'm going to give them little hash marks. That's your compound inequality. So you read it from the center. L has to be less than or equal to 3.025. That takes care of that. L has to be greater than or equal to 2.955. That takes care of that. All right, will the stock rods always meet the length requirements? And then explain. So remember, I had said that my stock rods, we'll call them the SRs, according to my reading, the plus and minus 0.03 gives me 3.03 here, because if I add the 3, which is what the standard length should be, I'm allowed to be less than or equal to 3.03 and greater than or equal to, subtract the 0.03, and I got the 2.97. So look at that. Will the stock rods always meet the length constraints? So is less than or equal to, what do you think? Looking at that, take a second, think about it. So let's work on the left side first. Is it true if it can be it has to be greater than 2.955, being greater than 2.977 meets the requirement, so I'm fine on that side. If it has to be less than or equal to 3.025, but mine is going to make it less than or equal to 3.03, it does not meet it. So I would say no, it does not on the higher end. So now looking at question G. Okay, and looking at our document, I think we had omitted this, so I'm going to leave that be. I'm going to talk through some of the remaining questions for the conclusion, because I think they're important also, and I want you to answer those as well. Alright, so here are the questions. Okay, so why do engineers place tolerances on dimensions? We talked about that in class, and it's basically so that you can allow for the errors in manufacturing, and you place the dimensions so that, the tolerances so that the parts will still work. Alright, that's why you have the tolerances. Not everything is going to be perfect every single time, but it doesn't have to be, and the tolerances allow for the imperfections in manufacturing. Okay, what are the three types of tolerances that appear on dimensioned drawings? So you need to know this by heart. You have the bilateral tolerance, you have the unidirectional tolerance, and you have the limit dimensions. You want to be able to call those up right away to your mind. Okay, then the last question, and notice the numbering is different here, don't let that worry you. The last question that you have to answer is, what is the difference between a general and a specific tolerance, and how can you tell the difference on a drawing? So remember, the specific tolerances are tied to a certain length or width or measurement right on the drawing file. So you'll have your measurement, whether it be the diameter or whatever, and then it will either give you a bilateral tolerance, a unidirectional tolerance, or a limit dimension measurement. So those are the specific tolerances. If there are no tolerances listed on with the individual numbers next to the pieces, then you look at the bottom, and there is a general tolerance. That general tolerance is tied to the number of decimal places after the zero, and it applies to all the not otherwise dimensional analysis, not otherwise dimension pieces that have tolerances. So if you just have a 0.4, then you're going to tie that into the general tolerance for decimal places of one place after the zero. So look for the text box on the drawing file when they talk about finding a general tolerance. And that's it. I would go back and look at your PowerPoint, make sure you understand what this section on tolerances is going to be about.